Hello, everyone. Welcome. Today, we want to talk about testing big data applications on Spark, Dask, and Array. So in this talk, we will first have a quick discussion about the general testing types, and then we will talk about the mindset and good practices. In the end, we will have a brief introduction to Fugue and to see how Fugue can help testing the big data applications. So in general, there are two main purposes for software and service testings. To verify the correctness and to verify the performance. On the low level, we have unit testing, integration testing, and regression testing. And on the high level, we have acceptance testing for correctness and stress testing for performance. In terms of testing strategies, if we pick unit testing, integration testing, and acceptance testing, then from the top level to the bottom level, we are moving from implementation validation to data validation. And we are moving from technology-driven to business-driven. And for big data applications, the upper level testings are always easier, faster, and cheaper. And more importantly, the upper level testings will have better test coverage. So now let's talk about the mindset when you design your big data applications and see how that can affect your testability of your project. So the first thing I want to talk about is separation of logic. So you must have a very strong sense of separation of logic when you design your application. And there should be several layers when you design your application. The first layer should be the core computing logic. That should be framework agnostic. And this part should be the most unit testable part. And the second layer should be the orchestration logic, where it has to be framework dependent. This part is more difficult and can be also slower to test. For example, if you want to test a Spark application, and then you probably have to have a Spark cluster, a local cluster. And that can take a lot of time if you have a lot of such tests. And on the bottom layer, it is framework-specific logic. For example, how do you create a cluster? How do you tear down that cluster? So for this logic, it's the most difficult part to test. So in general, this part should be covered by the acceptance tests. Let's take a look at the first example, subtract mean. So assume that you have a data frame. We want to group this data frame by the G column. And for each group, we want to subtract the mean of V from each value of the V. So here is a Spark, a native Spark implementation, PySpark implementation. Actually, this function is poorly designed. Why? Because in this function, as you can see, first of all, we include the Spark cluster construction logic inside this function. And also, look at this lambda function. This is actually the core computing logic when the data is already grouped and shuffled by Spark. And this lambda logic is actually just a pandas logic. But in order to test this function, you have to have a Spark cluster up and running. And also, you are not able to test the core logic because this core logic is embedded in the myapp function. So a better design for the subtract mean might be in this way. You can separate your functions to 3 different functions. The first function is your core computing logic, where the input and output are both pandas data frame. So this function has nothing to do with Spark. You should do full unit test on this function. And for the second part, which is Spark dependent, and we have modified this function to take in that Spark session where it does not need to construct that Spark session inside this function. And also, you can invoke this subtract mean inside this function so that you have minimized the Spark dependent logic in this function. And in the third function, It is all about how you create the Spark cluster or tear down that Spark cluster. So with this design, you will be able to move a lot of tests to the upper levels. So you can do unit test, integration test, and acceptance test on different parts. So the second thing I want to talk about is you should try to avoid framework-driven mindset. So remember that we talk about the 3 layers when you're designing big data applications. Actually, you should try to maximize the core computing logic that is framework agnostic, because this part is the most testable part, and it is independent from any framework, from any distributed framework. And for the second part, you should try to minimize the framework-dependent code. And for the framework-specific logic, of course, you should try to minimize. And more importantly, you should try to centralize the logic so that all the tests will cover that, and so that all the acceptance tests can make sure that the framework-specific logic is working as expected. Let's take a look at another example. So assume that we want to process a data frame. It has 4 columns, A, B, C, and D. They're all strings. There are some nonce. And what we want to do is, for any given row, if there are more than 1 non-null value, and then we just sort the values and concatenate them together as a new string, as a new value in the E column. But if there are too many nonce, then we just drop this row. So now let's see, with this business requirement, how we implement this logic in Spark, Dask, and Array. So in Spark, it's very natural to think about using map partitions, right? But if you want to use map partitions, there is a requirement. Your function has to take an iterator of Spark rows as the input. So but as soon as you put this iterator of rows as your input, this function is no longer independent from Spark. So in order to test this function, or in order to test any part of this logic, you have to have a Spark cluster. So the unit test becomes very, very difficult. The coupling is too strong. And if you want to implement this in Dask, then it's probably better. Dask is pandas-like, right? So the first thing comes to your mind, maybe that, okay, maybe I should use pandas apply. In order to use pandas apply, the requirement for this function is to taking a pandas series. The nice thing is that pandas series itself has nothing to do with any distributed computing frameworks. So it is just the local function that you can do the unit test. But the problem is this apply function, this apply semantic of pandas does not take care of filtering. So in order to do the filtering, you still have to have the filtering logic in my app. That means your core computing logic does not really cover the entire business requirement. And in order to test everything, you still have to have a Dask cluster. You still have to do the integration test. Right? So if you want to implement this logic in Ray, then Ray has less options than Spark and Dask. Actually, the only thing you could consider is using datasets and map batches. And in map batches, you can specify for each of the small batch, you can set the format to pandas, so that you can write a pandas code to solve your problem. And the nice thing about this function is now it has everything. It has the apply function. It also has the filtering. And so with this design, you have maximized the unit testable part. You have maximized the part that is agnostic to any distributed frameworks. And to be fair, Spark and Dask also have the similar functions to the similar APIs to taking core logic as the map batches function. But that will require you to learn more about Spark and Dask. And another thing is, because they have too many options, probably the first thing comes to your mind will not be this type of solution. right? So it seems like we have achieved the best structure in this code. But is this the best solution that we can do? So actually, if we take this core logic out, there can be an alternative solution. So look at this alternative solution. We will see that what if we taking the data frame as an iterable of list and output an iterable of list? With this assumption, actually, you can see that the code is very simple and very expressive. And this code has nothing to do with pandas. But the ugly thing is that in order to use this function, you have to convert the pandas data frame to two-dimensional Python array, process, and then construct the pandas data frame. So there is a concern that this wrapping logic can be time-consuming compared to the previous one where we just use the pandas native functions. But is that true? Actually, if you do the benchmark, you will see that this solution is 50 times faster than the previous solution. So let's take a step further. What if we just use this process logic as our core logic? So the core logic can be expressed in this way, right? This has nothing to do with any framework. It's just Python native. And this is the simplest one. And as we know, this is also the fastest one, even with the wrapping logic. So now the question is why it is not the first solution that we can think about at the first place. So assume that you are a beginner of Python. Assume that you don't know Spark, Dask, or Ray, and you don't even know pandas. This is probably the first solution you can think about. So what's the problem? I think the problem is we have so many tools to use. And so in a lot of times, we're distracted by the tools. In a lot of cases, our mindset is how to use XYZ to solve the problem. But if you can change your mindset, what can we do as much as possible before using XYZ? So if you practice in this way, you probably get more independent from those tools that works for you. And if you practice in this way, probably the first solution comes to your mind will be this one, the most expressive and the fastest one. Okay, now let's talk about good practices. So here is the last example in this presentation. We have NYC taxi example, which is pretty popular. And we know that the data set is publicly available on the website. Here is the background of the data set. The data range is from 2009 to 2022. And the data size for each paquet is from 50 megabytes to 150 megabytes. Each paquet file contains 1 month of data. And each paquet file has roughly 20 columns. Actually, we only need 2. The pickup date time and the location ID. So there are 242 different locations, and each row represents a write. What we want to do is, for each location, we want to build a time series forecasting model to predict the hourly total number of pickups. So as you can see, for this data frame, you will need some aggregations to aggregate on the hour and the location ID, and then to get the total count. And based on that, you want to build a forecasting model. I'm not going to dive deep into the technical details of this machine learning problem. Instead, we will just focus on this workflow. So on the first step, it is very easy for you to come up with a solution where to download 1 month of data, aggregate the location and hour. Also with no matter Spark, Dask, or Ray, it will be very easy to distribute this type of task to run this on full scale on the full data range, right? And on the second step, you will just union all data, repartition by location, and sort by hour now you get, for each location, you get a time series. You can train and predict, and to get the predicted value on the given horizon. And in the end, you just save the predicted value to a file. So now the question is, given this workflow, how do you test it? Here is the first testing strategy, which is also what I commonly see from data practitioners. Because the first step is fairly easy, so they just write everything at one time and run the full scale on the full data range. After that, what they do is they just do a spot check, ad hoc spot check, and see if there is any problem. If there is a problem, they will go back, change the code, and run at full scale again until there is no problem. And now the second step is just to implement everything on the rest of the pipeline. And then they just do another ad hoc spot check. And after these two spot checks, if everything looks fine, so they will just ship it. And think about that. The workflow that you shipped actually has no written test. And actually, there is no protection on the quality and the correctness. Right? So this is obviously a suboptimal solution. So now let's think in another way. How can we improve our the testability of the workflow? So first of all, it is trivial to write the code to get 1 month of data and aggregate by location and hour. Then why not just directly add a unit test to it? Similarly, union all data, repartition, and sort. This operation is also straightforward, and you can also have a unit test on it. And on the third step, train predict for one location, you probably can provide some mock data and to train a simple model and predict and to assert on the prediction. So you can have another unit tests. These 3 unit tests can cover almost the most part of your workflow. And actually, none of them will have anything to do with the distributed backend you want to use. Okay, now at this point, what you may do is just to get another month of data, right? And pick another location to do train and predict, and then to save everything to file. So now, probably at this point, inevitably, you will have to use the distributed backend you want to use, right? But at this point, you are still dealing with very small amount of data. So this is the best time to add an integration test. So for this integration test, you can use either Spark, Dask, or Ray to run everything end to end. But notice that you are still just getting 2 months of data and training on 2 locations. So it will not take a lot of time. It will not take a lot of compute resource. You can have very fast iteration if you find any problems. After this integration, now let's see, maybe we can run the first step at full scale. And now after you run full scale, I would recommend that you should add a data validation step as your acceptance tests. Data validation can run not only when you develop your workflow, but also when you run your workflow in production. So it is a very good way to protect your workflow. And now let's run full scale on train and predict. And let's add another data validation step as acceptance test. So then you can see that after this acceptance test, we'll have a very good, very reliable workflow. And it's well covered by unit tests, integration tests, and acceptance tests. To sum up, best practices. You should try to be test-driven. It is difficult, but if you get used to it, you will find it can make your pace faster and faster. Always try to unit test the small data on the core logic unit. It can effectively improve your test coverage. You should try to do integration tests before running at full scale. That can save you time and money. And also try to add data validation steps into the workflows as your acceptance tests. The last but not the least, I want to say that tests should reflect the requirement of each logic unit, no matter small or big. So they should be the most readable and the most expressive parts of your code. Okay, so now let's talk about Fugue. So Fugue is a unified abstraction of computing frameworks. As we know, on the local side, we have SQLite, DuckDB, Python, Pandas as our computing engine. On the distributed side, we have Spark, Dask, and Ray. So Fugue is a bridge between the local system and distributed system. It is an abstraction layer. It lets you write one copy of code that can run seamlessly and consistently on different backends, including local and distributed backends. So the value of Fugue in terms of big data applications is, in terms of testing big data applications, is that it removes the framework-dependent logic. So recall that we talk about the three-layer design for big data applications, right? So what Fugue can do is it can totally remove the framework-dependent part. Instead, it will have a very thin layer of Fugue abstraction that is also framework agnostic. So with this design, you will see that the need of integration test is almost non-existent. So let's take a look at an example. So here is the function that we talk about, the first example, right? So now let's see how we can rewrite my app using Fugue to make it more testable. We just import the transform from Fugue, and inside the my app, we just call the transform function, where you can notice that the input of my app has been changed, right? So the previous one takes in a Spark session and a Pandas data frame, right? Now we're taking any type of data frame, and we also have an engine parameter. So all these parameters will be passed into the transform function. So why do we want to rewrite in this way? Now let's see how we unit test this my app. In order to test this, you just need to pass in a Pandas data frame without setting the engine. So in this way, Fugue will just translate your logic into Pandas logic. So the transformation will just happen locally, and the output will just be a Pandas data frame. You can make assertion on that. So this is just a simple unit test. If you want to run this function at scale on different distributed backend, you just need to specify the engine to be Spark Session, Dask Client, or Ray. And also for the data frame, you can use Spark data frame, Dask data frame, or Ray dataset. You have the full flexibility, but for testing, you only need to care about unit testing. So here is the second example, the customer logic. As we discussed, the simplest version of this customer logic is also the best we can do, right? But the question is, how can we scale out this logic? So again, in Fugue, you just need to use this transform function. The data frame can be any type of data frame, Spark or Dask or Ray. And then you can directly use this core logic as your transformer to transform your data. The nice thing about Fugue is that it does not require you to use any certain data type as your input and output. It's not like Spark, Dask, or Ray. They have their specific requirements. In Fugue, it adapts to your own function. As long as you have the type annotation, let's see, the first example, we use Pandas data frame as input and output. And in the second example, we use iterable as input and output. But as long as you have the type annotation, Fugue will handle the data conversion for you. You can just focus on the logic and try to use the most reasonable and intuitive way to express your business logic. And also, by the way, for Fugue project, we keep the test coverage to be 100% all the time. So you can trust the system is reliable. Okay, on the third example, for the NYC taxi, think about that. What you can do is you can directly convert this integration test to a unit test, because at this step, you do not even need any distributed backend to test your things end to end. In addition, you can have the data validation using Fugue. For example, in last year's PyData talk, I talked about how to use Fugue and Pandera, Fugue and Great Expectations together to do scalable data validation. So here, what you can do is you can add a step where you use Fugue and Pandera together as the validation step. So in this way, even with the acceptance tests, you can run everything just using your local execution engine. And when you want to run this at scale, just change the backend and change the input. It will run at full scale. So in addition to this example, let's talk about the testability of SQL. So assume that in this workflow, we have already get all the data and save the raw data into a distributed data frame, distributed database. Let's assume this database is Hive, or you can assume this is, like, for example, BigQuery tables, right? So what we can do to extract the data is just using this very simple, very expressive SQL statement. But the question is, how can we test the SQL? What we often hear is that SQL is not testable. But actually, this is not true, especially with Fugue. So in Fugue, we have Fugue SQL, which is a superset of the traditional SQL. So here is an example how we tested this SQL. We import this fSQL function, run this SQL, but we just specify that this data source, hive.src table, to be a pandas data frame. And then we just run the whole SQL on DuckDB. What does this mean? This means we let Fugue SQL to identify the data source of this SQL and mark this data source using a given pandas data frame and run everything using DuckDB. So everything will just happen locally. And the output will also be a local data frame. So you can make assertion on that, and it can be just a pure unit test. If we take a step further, actually Fugue SQL can let you express your logic end to end. So the first step is to get data, and the second step is to use the transform function to do the distributed train and predict. And the next step is save, right? And this train predict function can be a pure Python function that has nothing to do with any distributed backend. It's fully unit testable. And for the whole pipeline, how can we test it? So actually, it is very similar. First of all, you just mark the input data source as a pandas data frame, and then just put this path as a local path, and run everything using DuckDB. After you do that, you will get a file at your local path. Just extract the data from the local path and assert on this data frame, right? So again, it is still a unit test. So how can we make this run on Spark or some other backends? You just need to remove this parameter, this Hive SRC table, so that this SQL will get the data from a real data source, and also change this execution engine to be a Spark session. And then your whole pipeline now will run just on the Spark backend and reading the real data source. So to sum up, all types of tests are useful. They are for different purposes. We need to use them strategically. And application design really matters. You should try to separate out framework independent logic and minimize the dependent part. And you should try, you should not be driven by your tools. Tools work for you, but you do not work for your tools. And Fugue lets you focus on the tool agnostic code. You can write less code, but with more test coverage. Thank you.
Thanks, Han, for such a wonderful talk on Dask. And yeah, we have a little bit of questions that people have put up. Yeah. So, do these 3 unit tests run at each step by Kestutis?
Do this 3 unit tests run at each step? Did you mean the, sorry, let me just change, let me see. Did you mean the 3 unit tests here? So these 3 unit tests, they are for different logic components. But if you want to run the unit tests, so the logic components, they should be written together, right? So the unit tests will run together. Yeah.
Okay, I hope it answers the question. Another one by Ludovico is I'm not sure I followed the reasoning behind the performance consideration when comparing the pandas and vanilla Python solution. Wouldn't the relative performance strongly depend on the data size? Your comments on that?
The reasoning of performance. I'm not so sure about the performance. What performance you talk about? I don't know which part you refer to. Sorry, can you clarify that? I follow the reasoning behind the performance consideration when comparing the pandas of vanilla Python solution. Oh, I see. Oh, I see what you mean. So the performance consideration, sometimes it can be true, sometimes it can be false, right? So in this particular case, we find that using the iterable is even faster than using the native pandas solution, right? So I think the point I want to make here is that pandas is not always faster than Python. And when you know pandas, people tend to have the assumption that, okay, pandas is always better, pandas is always faster. So if you become more tool agnostic, you could think more freely. And I think what is the most important is try to think about what is the real need for your business logic, right? And I think that is the most important thing. Performance is the second important thing. The example I want to show here is that native Python is not necessarily slower than pandas. So you shouldn't always assume that you should use one tool instead of another.